Hello there, and then welcome to a brand new lesson. Let's have beyond numbers. Now, in this lesson, we are looking at the three-set problem. This is the first of the three-set problem, and I'll use this to explain the structure and then the basic formulas we need to know before we can solve questions on three-set problem. So, without much ado, let's quickly look at how the structure of a three-set problem is. So, what I'm going to do is I'm going to take a first set, and then I would now take the second one and overlap it. Okay. So for the second one, let me just make it a red. And then I'm going to take a third one. We can also change the color as well. Okay. Then I'm now going to draw my universal set as a rectangle. So we have that here. I think we are good to go. So this is our three-set problem, or our three-set Venn diagram. Okay. Now, with that done, you would realize that we have all these partitions you see on your screen. Okay. So we are going to take our time and define each and every part so that we understand what it represents. And finally, we'll be able to develop our formula with understanding. Starting with the middle. So what I'm going to do is, let's start first of all with the individual sets. Okay. So if I'm to start with A, then what do we have in set A? If you look at it critically, realize that set A has I, it has I, it has Vn, and then Iv. That is all that you have in the circle of A. You see? So let's write that down. What then do you think set B is going to include? So as set B, that is, let's look at everything we have in the circle of B. So B is going to have, it's also going to have your I, and then we have I, then I, and then then I. That is this circle over here, all the elements in it, you see. And then you can pause and then get what C is going to have. Now, if you were able to get what I have on the screen, then it simply means you are paying attention. So now that we have all these three sets, let's now look at the intersections. So we'll first of all look at A, then intersection your B. What do we mean by A intersection B? So the elements that are in A and are also in B. You see, so looking at it carefully, you realize that we have what? We have I, and then I. Then if you come right to the Venn diagram as well, you'd see the same thing, that you have I and I both in what? A and B. So that is going to be our I, and then I. Then we come to our A and C. So the elements that are in both set A and are also in set C. So looking at it from the Venn diagram as well, we have I and then IV. You see. Then we want A. This time around we want B intersection C. So B intersection C. And that is also looking at it from the Venn diagram. These are the elements we have both in B and then C. So it's going to be I and then I. With that, I think we are making progress. Now you realize that this portion over here is both, no, let me say it is in A. You see, if you draw the circle of A, it cuts I. If you draw that of B as well, it cuts I. You see, then if you draw that of C as well, it also cuts I. So we would say that I is the intersection of all the sets. You see, I is the intersection of all the sets. So how are we going to write that? That is A intersection B, then intersection your C. And that gives us what? The element I. Now, these are the basic regions we have in our Venn diagram. Let's go further. Now, you'd realize that even though we are saying all of this here is A intersection B, but we still have a portion in A intersection B that if you draw your circle of C, the circle of C, it is not going to touch it. Meanwhile, the A intersection B, which is all of this, if we have to look at the circle of C, there is a part of it that still steals some of the element in the A intersection C. So there is a notation for this portion, and then this portion as well. How do we notate these portions? So we are going to say that this portion over here, that is the I, it is actually an A intersection B, all right, but we are removing that part that belongs to C, that falls in C's circle. So you see, it is in A and in B and not in C. So C prime, this is what we are adding to it this time around. You see that? So it is in A and then it's in B and it is not in C. You see, and that becomes our what? Our I. That is where we have the element I. Now, what of Ivan? Ivan, if you look at it carefully, it is in A. You see, it is in the circle of A. It is also in the circle of C. You see, that is Ivan, but it doesn't include any element in the B. So we would say it is in A and then in C, but not in B. Do you see that? So this is how you are going to write it. Now, all we did was to bring our complement symbol on the B. You see, you can choose to write it as A intersection C intersection B prime. It doesn't change anything. Okay, so the order in which you write it doesn't matter. The most important thing is you putting your complement on the B to show that it is in A and then in C, but not in what? Not in B. That is not in B, but then it's in the complement of B. You see that? So that is going to be what? Our I then. So the very last one, which is I, what do you think is going to be? You can pause the video and then let me know in the comment section. So as you might have rightfully written, it is A prime intersection B intersection C. That is the element we have in C, also in B, but not in the circle of A. You see? Okay. Now there's also another part we want to identify, and that is these lonely elements over here. You see? So for these lonely elements, you realize that it is in, for this very first one, which is V, it is in A only. A only. For this here as well, it is in what? B only. And then for this here, it is also in C only. In English, we'll call it A only, B only, and C only. But then, if you want to use our notations, then we'd say this here is in A. So let me just put it here. It is in A and it is not in B. You see, so the complement is on B. And it is also not in C. That is how we are going to write that. You see. And for this portion over here, which is VI, it is going to be what? It is not in A, it is in B, and it is not in C. So guess what this is also going to be, as I write it here for you to clearly see it. So just as you might have written, this is what is going to be. That is Venn II is going to be what? A prime intersection B prime intersection C. That is Venn II over here. Now look at it carefully and let me know. Is there any region we have not yet identified? Do you see any region that we don't have on our list over here? Yes, there is this very last region over here. That is Venn III. And VII is not in A, it is not in B, neither is it in C. So if we take the union of all the sets, it is outside them. Okay, so how do we write that as well? So that is what you see over here. Now with this, we have covered all the regions that are of most importance if we want to solve a Venn diagram involving three sets. As usual, I'll leave you with some questions. This time around, my questions are just for you to identify 3 areas. You can let me know in the comment section what they are. So these are the regions, just 3 of them. The first one being A prime union B union C. Then the second one is just A prime. And then the third one is A intersection into bracket B union C prime. All you need to do is first of all identify whatever you have in the bracket first. If there is a bracket, then gradually you will get your desired answer. This is how Beyond Numbers, where we learn maths the easy way. If this video was helpful to you, you can choose to like and then subscribe if this is your first time and you so do wish to receive notifications when I release a next video. See you in our next lesson, where we solve practical questions. First of all, looking at the formula we need for 3-set problems and then solving some practical questions as well. Bye for now and stay blessed.